Thanks for joining the webisode on Systems Manager. Today we're going to explore Systems Manager and how to build a foundation for enterprise cloud operations. My name is Terry Johnson, and I am an enterprise solutions architect at Amazon Web Services. So in this short intro, we're going to highlight the following. We're going to do an overview of AWS Systems Manager, inventory, run and automation, maintenance windows, change calendar, state manager, and parameter store. We're also going to demonstrate how to utilize each of these features within the AWS Systems Manager. So in the past, organizations have had to choose between either innovating faster or maintaining control over cost, compliance, and security. With AWS Management and Governance Services, customers do not have to choose between innovation and control. They can have both. With AWS, customers can enable, provision, and operate their environment for both business agility and governance control. So what is AWS Systems Manager? AWS Systems Manager gives you the visibility and the control of your infrastructure on AWS. Systems Manager provides a unified user interface so you can view operational data from multiple AWS services, and it allows you to automate operational tasks across your AWS resources. So let's dive a little bit into what some of the benefits of having AWS Systems Manager is. So shorten the time to detect problems. Right now on premise, a lot of us have tools that we utilize to go and monitor for resources that may fail. That could be hard drive failures, that could be memory consumption or CPU consumption, and we're identifying that there is a problem. Maybe a website no longer responds. But one thing that's so great about speeding up and shortening the time to detect a problem is that within AWS Systems Manager, you can actually group resources together to combine to say that this is an application. So for example, if you have an application that utilizes Amazon EC2, which is our elastic compute service, our Amazon S3, which is our object-based storage, and Amazon RDS, which is our relational database service, you can use Systems Manager to create a resource group for that application and easily see what software has been installed on your Amazon EC2 instances, any changes that were made to S3 objects, or database instances that have been stopped. Another thing about the cloud, right, which is one of the benefits of moving to the cloud, it's being able to automate things. So easy to use automation, right? With very little code, it's going to enable you to automate operational tasks that are going to help your teams be more efficient. So with automated playbooks, along with the rich text descriptions, you can reduce human error and simplify maintenance and deployment tasks on your AWS resources. So you can create what's called predefined automation playbooks or build your own to share for common operational tasks. And we'll look at this a little bit when we get into the demonstration. So you have the ability to improve your visibility and control. Right now on premise, we go through hardware refreshes in which we find a rogue server in which we have no idea who owns it, what the application is doing, is it being patched, or are we even monitoring it? So being able to have that visibility and control within System Manager is going to easily help you understand and control the current state of your resource groups. You can also view detailed system configurations, operating system patch levels, software installations, application configurations, and other details about your environment through your Systems Manager Explorer. We'll be discussing System Manager Explorer in a different webisode, but for now, remember, there is a unified dashboard to view all your resources. Systems Manager is also integrated into a service that we have, which is called AWS Config, so you can easily view what changes have occurred to your resource as they occur over time. We're going to explore AWS Config shortly. You can manage hybrid environments. So we talked about that rogue server that you had on premise that you didn't know anything about. With AWS Systems Manager, you're able to not only manage and control the resources that you have within AWS, but you can manage and control the resources which you have on premise. So that helps you have a unified view of managing your Windows and Linux operating systems run on Amazon EC2 or on premise. Also, maintain security and compliance. At AWS, security is job zero. So being able to maintain that security and compliance by scanning your instances against your patch configuration and your custom policies. So you can define patch baselines, maintain up-to-date antivirus definitions, and enforce firewall policies. You can also remotely manage your servers at scale without manually logging into each servers. And once we get into the demo, we're actually going to do that, and we're going to see how we're able to do that. We can also use Systems Manager to centralize the storage and management of our configuration data, whether that be in plain text or in database strings or in secrets or such as passwords. This is going to allow you to separate your secrets or your configuration data from your code. I think we've all had nightmares in which we've had code that had hard-coded server names, hard-coded URIs, hard-coded passwords, and hard-coded database strings. And we don't want to have that. We want to have a centralized place in which we can store those things, make version updates to them without having to affect the code. So I talked a little bit about AWS config, and we're not going to go too in depth into it in this webisode, but we will enable it when we get to the demonstration. But I want to talk a little bit about what AWS config is. So it maintains a real-time inventory of your cloud resources, and it maintains the current and historical configuration of the cloud resource over time. So you enable it, and what happens is it takes a snapshot in time of what's going on with that resource. And as things change, it takes another snapshot. And this is very, very important when it comes to your future viewing. What has changed? Who changed it? When did it change? Right? And then seeing how it correlates to an issue you may be having, whether that may be security related or it could just be simple troubleshooting for an issue. It also provides API access, which is going to allow you to take actions if something happens. And what I mean by that, let's say you have an S3 bucket. You don't want that thing to be public because we've seen issues with that before. Well, you can create an action in which you say, it's public. Now I'm going to go back and make it not public because I don't allow that. So let's talk a little bit about the features that come within AWS Systems Manager, which is pretty great. It's pretty great. And it grows every day. So right now today, because Systems Manager is so big, in this webisode, we're going to cover parameter store, change calendar, automation, inventory, run command, and state manager. But for now, let's move on to inventory. So we have what's called the quick setup. And with a few clicks, it enables Systems Manager capabilities across your accounts and your regions. And during this process, AWS config is actually enabled. So it's an easy button for you to click without having to do all the manual setups yourself. Can you enable AWS config manually? Yes, you can. But this is just going to make sure that all of the best practices are included when you do it. So it's going to scan all of your instances for any missing packages. And as you see here in this example, we have some that are failed, we have some that are success, we have all kinds of different things that are showing up. It's going to update your Systems Manager agent, and that's going to be important for you to be able to actually communicate with the systems. Right now, we install agents for all of our monitoring and things that we do, and Systems Manager is no different. It comes with an agent, and that's going to allow for the collection of inventory for all of your instances. It also can allow you to install and configure your CloudWatch agent, which we'll see as well in our demo. You can create and configure IAM profile roles too. And profile roles, which are a little bit like, think about service accounts. It's going to invoke something on the behalf of the service, right? So you're using it that way. It's not going to be an IAM account or a person's regular account. It's going to enable accounts across regions and cross accounts and regions. And it's going to set up something called Change Manager. And we're going to talk a little bit about that later. So let's move on to the run command. I talked a little bit about being able to run commands without having to actually log into a system. And that's where run command comes in. So it's going to allow you to execute control actions across any and all of your nodes in a fleet. And a fleet is all of your servers that you have there. And it's going to do some of those common tasks that you'd like to do. Things like bootstrapping. Maybe I have a server that comes up and I want to install Apache on it, or I want to make sure that it's up to date on its latest patches as soon as it comes up, or build a deployment pipeline. As soon as the server comes up, we're going to deploy a particular thing. Capturing log files when an instance is terminated using an auto-scaling group. Auto-scaling is utilized for adding servers to a group as load increases or decreases. And when those servers get terminated, we want to keep that information, and we might want to log it. So some of the common uses that I said before is to be able to join an instance to a Windows domain as soon as it comes up, and many, many more that you can do. Then we have automation, which we talked about earlier, right? So you can build automation workflows to configure and manage instances and AWS resources. So you can create custom workflows, or you can use predefined workflows that are maintained by AWS. And we're going to actually go a little bit deeper into this. And why would you want to do that? For the same reason, you want to perform those common IT tasks. It's going to simplify those IT tasks, such as changing the state of one or more instances using an approval workflow and managing those instances according to a schedule. So safely being able to perform disruptive tasks in bulk, right? So I want to go out and I'm going to patch a whole bunch of servers at one time, or simplifying a complex task. Having one-click automations for simplifying complex tasks is creating a golden machine image, which right now today on premise, you have a standard image that you use. And so you could utilize automation to be able to do that as well in the cloud. And then you can also share best practices. So automation lets you share your best practices with the rest of your organization. So let's talk about maintenance windows. Maintenance windows is something that we're all familiar with in the IT world. This is when we do our maintenance on our machines. So we've taken that into account when it comes to systems manager. So maintenance windows are going to let you define a schedule for when you to perform potentially disruptive actions on your instances, such as patching an operating system, updating drivers, or installing software patches. And it'll also let you schedule actions against numerous other AWS resources. So let's say you have a system that you're going to be patching and it's going to impact another system downrange in the pipeline. You can actually schedule these actions to be in line with what you would be normally doing with your other resources that it is interacting with. So you can use your maintenance windows to install or update applications, apply patches, install or update your systems managed agent, run PowerShell commands or Linux scripts by using a run command, which we talked about earlier, build out Amazon machine images, which we said is for before that, and perform tasks like removing an instance from an elastic load balancer environment and then patching that instance. We all know right now in our maintenance windows, we have a method to our madness. There's the way that you shut things down, and there's the way things that can start up. And utilizing maintenance windows and automation, you can automate the time and when to shut things down, to patch, and to start things up. So let's talk about change calendar. So we all have maintenance windows that we adhere to, but they're generally in line with some type of change management process that you have. And the good thing about change calendar is that it lets you set up a date and times and ranges when actions that you specify, for example, in systems manager automation documents, that may or may not be performed in your AWS account. So let's say you know that at the very end of the month, you run all your financials, no changes are to be made, or the Christmas freeze that everyone likes to do, no change being made around Christmas. You're able to go into the change calendar, block those times out, and then when things are done through different services within Systems Manager, it will check the Change Calendar API to see if it is okay for you to do this. It also comes with a built-in approval workflow. So if there is something that needs to be done during a blackout period that has been approved, that you can get override approvals. So State Manager. State Manager is a secure and scalable configuration management service that automates the process of keeping your Amazon EC2 and hybrid infrastructure in a state that you defined. One thing that we found on premise is trying to ensure that everything is in line with what we think it should be. They're patched how they should be. They have the things on them that should be running. Everything is happening in a consistent manner. What State Manager is going to do is some of the same things that we talked about before with Run Command about, configuring network settings or doing bootstrapping to do a specific system at startup, or patching the instance and running scripts on Linux and Windows systems. The thing about State Manager that's so great is that it keeps consistent of what that state is. So if someone was to go and make a change on these resources without going through the State Manager to do that, it will detect that drift. It will alert you of that drift and then allow you to remediate that however you want, whether that be that you just go ahead and you manage it through the State Manager, or you actually remove that change that was actually made. So parameter store. We talked about being able to store data like passwords and database strings and license codes as parameter value. And we talked about why that's so important to be able to do that, because you don't want that inside of your code. It could lead to lots of problems, right? Things breaking in the future because no one remembered that that's what the database string was and it got updated, or the password gets exposed because it's sitting in the code. And the great thing about parameter store is that it supports not only unencrypted data, but it supports encrypted data utilizing our KMS, our key management service, for encryption. So you're able to just decouple your passwords and your secrets away from the code itself. So you can utilize it to store parameters for things like Amazon EC2 instances, our Elastic Container Service, Lambda, which is our serverless code service, CloudFormation, which we use for infrastructure as a code to deploy things. And you're able to just be able to call up these values without them being exposed. So here we have some of the resources, and we have a blog on management and governance, and we also have a news blog where we talk about AWS Systems Manager and our product page. We also have our feedback email address, which we encourage people to use when they have feedback. 90% of the customer feedback that we have go into the creation of new services and features. So let's go ahead and move into the demo. In this section, you'll create a test Amazon Linux 2 Elastic Compute instance. You're going to enable AWS config to monitor and record your AWS resource configurations. You're going to use AWS Systems Manager Quick Setup to enable Systems Manager's best practices. And then we're going to create a simple storage service S3 bucket to store our Systems Manager inventory data. And lastly, we'll create a resource data sync to send inventory data to that S3 bucket. So we'll need to open the CloudFormation template from the URL that is listed. Let's copy all of the lines into Notepad. And then we will save the resource as a YAML file. Once we have done that, we'll go into our CloudFormation web console. And we're going to create a stack. We're going to upload the template in which we just saved. And then we're going to click Next. In the stack name, we're going to put in SSM Web Workshop, which is annotated inside the workshop itself. And then we're going to click Next. Then we're going to click Next, leaving all defaults. And then we're going to create that stack. Then it's going to start to create our EC2 instances within a VPC with an internet gateway to allow inbound access from the internet. This could take up to 5 minutes. So let's talk a little bit about enabling AWS config using quick setup. So AWS config is a service that enables you to access, audit, and evaluate the configurations of your AWS resources. It continuously monitors and records your AWS resource configuration and allows you to automate the evaluation of recorded configurations against a desired configuration. So what does that mean? I say I don't want public access for my S3 buckets, which is my desired configuration. Public S3 bucket is created. So with config, you can review changes in the configuration and relationships between AWS resources. You can dive into detailed resource configuration histories. You can determine your overall compliance against the configurations specified in your internal guidelines. And this is going to allow you to simplify your compliance auditing. It's going to help you with your security analysis, your change management, and your operational troubleshooting. Like I said before, just being able to go back and see what has changed over time. So it's going to help with that. So in order to enable AWS config, we're going to actually go over to the Systems Manager Quick Setup. And when we run Quick Setup, like I stated before, it's pretty simple what we'll see. It's going to deploy Systems Manager in a way that has across multiple accounts and across AWS regions by integrating it within AWS organizations. So we have completed. So if we go here back to EC2, we'll see what virtual servers were actually created. So we're going to go to the instances that are running. And as you see here, we have two of them, App 1 and App 2. So let's go over to Systems Manager. And let's navigate to the very top to Quick Setup. So let's choose the home region that we want to be in. I wanted to do this in Northern Virginia, so I'm choosing US East 1, and I'm going to select Get Started. We don't have any configurations just yet, so we're going to create one, and we're going to do a config recording. As it states here, enable the tracking and recording of changes to your AWS resource types. So we're going to click Next. So here, we're going to go through here and do our configuration options. So we're going to choose specific resource types, and then we're going to select which resource types we want. So I'm going to type in EC2, and we want instance. And then I'm going to type in AWS SSM. And we're going to do all of these: associate compliance, file data, manage instance inventory, and patch compliance. And we're just going to check and make sure we have them all here. We're going to select create new S3 bucket for our delivery settings, which we talked about. We want these things to eventually end up in an S3 bucket. We're not going to stream the notifications, but you can set them up in a real world scenario to send you notifications on these. For the schedule, we're going to keep things as the default. We're going to have current region, and then we're just going to create. So when this happens, System Manager in the background is actually deploying a CloudFormation template. And that's going to enable AWS config based upon those parameters that we have selected. So let's go ahead and go to CloudFormation and see if we can see that template. So here we are. We're creating progress. We can go and actually view the events and see exactly what it is creating. So as we see here, it's creating that role that we talked about, that service account, for lack of a better word, that's going to do these things on your behalf on the EC2 instance to allow Systems Manager the ability to communicate with the systems to the AWS resources. See here, it's enabling Explorer, which we talked about earlier. It's creating that association. So it's associating these instances with this particular setup. And now we're complete. So now if we go to AWS config, and we go to resources, we now see our resources here. So we have our EC2 instances that are here. Go here. We go to view details of our resources. We can also view what it is in JSON. So let's go back to Systems Manager. I'm going to select Quick Setup. We're going to see our configuration is going to load right here. So we see succeeded. I'm going to select the radio and view details there. And as you see, we have a success. We have two configurations that are associated, which are the accounts that we had. If we go here to the radio for our account and do view details, we can see that they're there and that they've been enabled, both of them. So let's go to enabling host management. So we're going to go back to our quick setup again. And this is talking about, when we talk about host management in the configure as a configuration type, is automating those common and recommended tasks that we had for systems manager, right? So that's going to include requiring that IAM instance profile role and setting up those operational best practices, but from a host perspective. So what we did before was config recording, which was the resources themselves, but now we just want to talk about the host to the EC2 instances. So we want to make sure that we have everything selected for systems manager and that we have all of those highlighted. So here you see we have the Amazon CloudWatch. This is what I was talking about earlier when you can install and configure the CloudWatch agent and then update it. We're not going to do it right now. We're going to do a little bit later in the demo, but just know that you can do it from the quick setup. As far as regions, we're going to leave it at the current region, and we're going to choose all instances, and then we're just going to create. So like we said before, this is also going to kick off another CloudFormation template in the backend. So you can simply just go to CloudFormation Web Console. And you see it's creating progress. You can actually go to the events and see exactly what it is doing, right? So we see here is updating the profile, scanning for system patches. It's got the role for automation. It's creating and attaching it to the instances. Again, we're associating it to enable it in Explorer, creating the IAM role, the identity and access management, to the instance, and then we're done. So if we went back to Systems Manager in our quick setup, we should have two configurations now. So here's our host. We're going to view details on that. And there we are. So we have all of our associations. So if we're going to view details on that, here we go. So we got our collect, we have our update, we have our scan, enabling the Explorer, and then attaching to the instance. So we have 5 associations that were created. So let's also go and take a look to make sure that what we wanted to be changed actually was changed. So we said we needed to have that role attached to our EC2 instances, and that was the whole point of doing the quick setup for the resources and for the host. So if I was to choose one of these app servers and go to security, we should see that role is attached, and here's the role. Check the second EC2 instance, same thing. So it has the role has been associated with it. So let's configure an S3 bucket. And this is our object-based storage. And this is where we're going to want all of that data that we're collecting for inventory to go into. So we're going to send all of our inventory data from all of our managed instances into one single bucket. And what the resource data sync does is then it's going to automatically update that centralized data when new inventory data is collected. So let's go ahead and create a new bucket. We're going to use your first name. It's SM Workshop. We're in Northern Virginia, so that's what we're going to do. We're going to keep all of the defaults the same here and just create the bucket. So now we're going to click on our bucket. We're going to go to permissions. And we're going to go down to bucket policy. So we're going to edit that and we're going to create our own policy. That's going to allow us to be able to actually write from Systems Manager into this S3 bucket. So we're going to copy and paste a snippet, code snippet that we have within the workshop. What we need to make sure that we do is that we change this to what our bucket name is. right? So my bucket name is my first name, last initial. So we're going to make sure that we put that in there. And we also want to make sure that we put it here in this area too. If you forget to do this, you will get an error. So just make sure that you're going to go back and put that in there, plug that in. Once you've done that, just go ahead and save those changes. Then go down, we want to make sure that we see the bucket policy here, and it's here, and it has the correct S3 buckets. And as you see here, we're going to allow Systems Manager to put objects in that bucket. So let's go ahead and create a resource data sync. So we're going to ship all of our inventory data to this S3 bucket. So let's go ahead and put the link that we have in the workshop there, because it's the easiest way to navigate to that web console. And we're going to create a resource data sync. So we're going to call our sync name, my name, inventory, S3 sync. And the bucket name, if you did not capture the bucket earlier, we could just open a new tab so that we can grab our bucket name. So our bucket name there. We're just going to copy that. The prefix, it says optional here, but we know that we want just the inventory. So we're going to tell it, create a folder, which is basically what a prefix is, called inventory. The region is going to be this region. Note that you can encrypt this if you like, utilizing our key management service. But right now, for this purpose of this particular demo, we're not going to do that. So we're going to go ahead and create that resource. You see that it's successful? So let's go ahead and hop over to S3 and see what we have. So you see inventory, which is the prefix in which we said we needed. And here we have our instance information that's coming in. So far, we just have that. So if we scroll down, we see that we have lots of different data that's being poured in. The cool thing is once you have all of this data inside of here, you're going to be able to utilize this with Athena, which is our analytics service, and use QuickSight, which is our business intelligence tool, to gain some deeper insights into the inventory that you have. We're not going to go into that within this workshop, but within the workshop itself, in the web browser, you should have the user guide documentation as well as a reference architecture to what that actually looks like. So we're just going to let that continue to run and gather inventory as it goes along. As you see, it's still starting to update things, but let's go ahead and move on to codifying your run books for common tasks, right? So we talked about run command, we talked about automate. So we know that within the run command and automate, we have what's called an AWS Systems Manager document or an SSM document. And this is going to find the actions that System Manager can perform on your managed instances. So System Manager includes more than 290 pre-configured documents that you can use by specifying parameters at runtime. And those documents can use JSON or YAML format. So whichever you're more comfortable with. Some people like JSON, some people like YAML because it's a more friendly format to work with, and we support both. And so within those documents, you can include the steps you want to take and any parameters that you need to specify. So you can use predefined AWS documents, which we'll see, or you can create your own depending on what your use case is. So as far as the run command, we talked about that a little bit. It's going to let you remotely and securely manage the configuration of your managed instances. And a managed instance is any EC2 or any on-premise machine in your hybrid environment that you've configured for Systems Manager. So if it has that agent on it and you've configured it to be managed by Systems Manager, you can use the run command to enable you to automate some common administrative tasks and perform some ad hoc changes at scale. So let's go back to Systems Manager. And we're going to do create a document commander session. And we're going to give it a name. We're going to call it org install app because we're going to want to install an application. The target type, we're going to keep it blank. It's optional, but you can fill it in. And we're going to leave the document type as command document. And what we're going to do is we're going to copy the content from our workshop into the content section here underneath JSON. So we're going to delete this out and we're going to put this in. And as you can see here, what we're doing is we have a description, and the description is prepping a web instance. We have the action, which is running a shell script. And then you see here, we're going to install Apache, and then we're going to create a directory, and we're going to put a text in there called hello text, and then we're going to start the Apache server up. So we're going to create that document. So we're going to go owned by me. So as we see here, we have owned by Amazon, owned by me, shared with me, and then we have all documents. Owned by me is the quickest way to see what we've created. So you see the things that we've done earlier today. So here's our install app org. So if we select that, you can create a new version, delete that document, or modify it. So let's go ahead and run this against the managed instance. So we're going to go to the left-hand pane, and we're going to go to Run Command under Node Management. So let's go ahead and go to Run Command. We're going to go Run Command. And then we're going to search by owner and owned by me. And then we're going to see that we have our org install app there. We're going to select latest version at runtime, but you can select any version that you like, but we only have one. Here's the message that we have to display, which is prepping web instance, and I'll show you where we're going to actually see that at. And in the target section, we're going to choose ours manually. You can use tags, which is a way of being able to identify resources within AWS with a common name, but we're going to do manually. And so we did that. And so we're going to leave the parameters such as other parameters and rate control. We're going to leave that as default, and we're going to uncheck enable S3 bucket. In a real world scenario, you would want to log this. And then once I show you why, you'll definitely understand why it's important to have that go to an S3 bucket. But we're just going to run this. So we see that it's running and it's in progress, and we have success. So I'm going to select, go back to the run command, and then I'm going to select my history. We're going to view details. And as you see here, we have the command steps that we're taking, the date that it was requested. You see here that's talking about the parameters themselves, success of it. So here we have an error, right, saying that it's been altered outside of Yum. But the thing that I really wanted to highlight to you guys was the output. So this is what's happening as we ran through. So you see here it is running through dependencies to install HTTPD. It resolved those dependencies, and now it's starting to install what's needed for the web server. And you're able to see everything that was installed and all the dependencies and see that it completed. The reason why I talked about in the real world you would want this to go to an S3 bucket is because the command output displays a maximum of 48,000 characters. So if you go beyond that, your output will be truncated. But if you have it going to an S3 bucket or utilizing CloudWatch, which we'll talk about a little bit later logs in order to log this stuff, you can go in and see the full output without it being truncated. So let's talk about defining freeze periods and access control. So we talked about change calendar and about being able to say during this time of the month or these particular days, we're not going to be able to make any changes to these resources. So there are two types of change calendar entries that you can have. We have default open, which are actions that can run by default, but are blocked from running during associated events, right? And then we have default close, and these are actions that you do not run by default, but they can be ran during events associated with a calendar entry. So think about these as a standard and a non-standard change, I guess. Default open is a standard, default close is not so much a standard change. So in this lab, we're going to open a default calendar. We're going to create an event in it, and then we're going to create a custom automation runbook that we talked about earlier. And then we're going to run an automation runbook to see the workflow being blocked by the calendar. So we're going to go to change calendar underneath change management. And we're going to create a change calendar. Calendar name is going to be your first name, cal open. We're going to select open by default, which are actions that can run except during a scheduled event, like a change control calendar. And then we're going to create that calendar. And what's going to happen is it's going to create this 2.0 iCalendar. So we're going to go ahead and click on that calendar name. And here we have this nice calendar. So what we're going to do is create a scheduled event. We're going to call that event your first name, no changes. We don't want any changes to happen on that. And we're going to set that time for today and ending tomorrow. Just be sure that when you do this, that you're setting it for your time zone. Another thing that you should note is that you can set up a reoccurrence, right? So that could be daily, every day. And this is for people who have standard change management windows for their maintenance windows. So you could set this up or something where you know a certain time of the month you don't want any changes to happen. So let's go ahead and create that scheduled event. And we see it here on our calendar. And go to our description. And let's go to the calendar use. So what I want you to see here is that we have the calendar names, which are the list of calendars to check for status. And basically we're saying that anytime something happens, the first thing that's going to happen is that we're going to go and check and see if there's a change in the calendar that's going to either allow it or not allow it. And this is the CLI that's happening, where it's saying, check these calendar names in this region first. So what we want to do is make sure that we copy this here and make note of it. So I'm going to take that and put that in our notepad. So let's go ahead and create an automation runbook. And let's see how well this works. So we're going to go to documents, not to automation. And the last time we did a command or session, which was the run command, now we're going to do automation. So we're going to call this your first name, stop instances, check calendar. So what we want to do is actually check and see, can we stop instances during that window in which we set? So we're going to go to the editor tab and we're going to click edit. It's okay, say okay. And we're going to take the code snippet that we have within our workshop and replace what's here in the document. What we want to make sure we do is this here. Remember we copied the Amazon resource name earlier? Well, we want to take that we copied and we're going to replace it out of that code snippet. And it will look just like this. and then we're going to go ahead and create the automation. So let's go to Owned by Me. Here it is. So this is what we have for our inputs, which is our calendar name that we put there. And these are the steps we want to perform, which is stopping an EC2 instance. So now let's go to automation. We're going to execute automation. We're going to go Owned by Me because it's just simple to find what we need. We're going to select Next. We're going to do a simple execution. And then we have our parameter inputs, right? So let's go ahead and go to Services, type in EC2, and let's open that in a new tab. What we're looking for is the instance ID. So we're just going to choose one. I'll choose app 1 for this particular example. And I'm going to copy the instance ID, which is here. We're going to go back to our automation UI, and we're going to put in our instance there. One thing I want you to see is the AWS command that's actually being generated. And this is it. This is a shareable link, so you could share that link. And you see here it's saying, I want to execute this automation against this instance ID on create. So now we're going to execute it. So it is running. And now we've said we don't want anything to be changed today, right, until midnight into tomorrow. So what we expect for this to happen is for this to fail. So, and it did, and it failed, because that's exactly what we want. In a real world environment, like I talked about before, you can add an override approval mechanisms to your automation runbooks so that you can allow specified approvers that are in a list to review if the automation runbook should proceed through the calendar if it's in a closed state. So this is going to provide an easy and reliable way to fully automate your process, and it's going to also prevent any undesired changes during critical time periods. Inside of the workshop, I do have a link there that talks about using Change Calendar and Systems Manager automation to override those approval mechanisms, and it's a really good blog. But in episode 4 of this workshop, we're going to actually integrate Change Calendar into Change Manager, which we haven't talked about too much. And this is going to ensure that change requests only take place during an appropriate time. So let's move on to enabling configuration using parameters. When we talked about parameter store. So here we're going to do 3 primary things. We're going to use State Manager to configure things. We're going to have parameter store, and we're going to do Amazon CloudWatch, which is our AWS monitoring tool and logging tool. And we didn't go too in depth in it before, but we will look at it a little bit more now in this particular part of the demo. So what we need to do is go into IAM, and this is our Identity and Access Management console within AWS. And we created that role earlier. And what we need to do, that role allows Systems Manager to be able to talk to the EC2 instances, which is great. And then we created a bucket policy earlier that allows Systems Manager to be able to write to an S3 bucket. Now, what we need to allow now is for CloudWatch to be able to communicate, right? So CloudWatch also has an agent that allows you to only monitor metrics like CPU and memory, but also be able to monitor any applications that are installed there. So let's say you have Apache or Nginx installed, you're able to go and look at those logs and have them collected. So now we're going to go into our roles, and we're going to allow CloudWatch agent the ability to be able to interact with the EC2 instances as well. So we're going to go to that role that we created during the quick setup, and we're going to attach a policy that's going to allow CloudWatch agent to be able to interact with these EC2 instances. So within here, we're going to look for CloudWatch. We're looking for the agent server policy, which is here. And we're going to take that, and we're going to attach that policy. So now we're going to be able to get metrics using CloudWatch and the CloudWatch agent. So we see that it is there, here. So now we should have 3. So we have our patch association, CloudWatch, and a managed instance core. So now let's go over to the parameter store. So we're going to go back to Systems Manager. We're going to go to the parameter store, which is going to be underneath Application Management. And we're going to create a parameter. So we're going to use the name that's in the workshop, Amazon Test Instances. Description, we're going to leave blank. We're going to have the tier is going to be standard, so we're going to leave that way. Type is going to be string. You can do string, which is any string value, separate strings using commas, and a secure string, which we talked about before. So if you had passwords that you wanted to make sure that that was encrypted. We're going to leave it at a default value of text because we're going to put that text in here. So we're going to copy that from our code base within the workshop. Okay, so now we're going to go ahead and create that parameter. So we had that there. So now what we're going to do is go to State Manager. So we're going to go back to Systems Manager. Then we're going to select State Manager, which is going to be underneath Node Management. And we're going to create an association. So we're going to call it CloudWatch Agent Install because we want to install the CloudWatch agent. And we want to be able to configure a package, right? So that's going to be the document that we're going to use. So it didn't work so well, but here AWS configure AWS package is what we're going to select. We're going to leave this default for install and uninstall and reinstall. Now, when it comes to the name that we're going to do, we're going to call it Amazon CloudWatch Agent. We're going to leave version blank like it is here. And when it comes to targets, we're going to choose instances manually. We're going to select both of our instances. We're going to do it on a schedule, but we're going to do cron in a rate expression. And what we're going to do is say that rate is 1 day. And as you, with anything that we've been doing today, you're able to write this to S3 if you needed to. But let's go ahead and create the association. So here we see that it is pending. And here we are successful. So we have installed it. Here we are. So let's go ahead and try to configure that CloudWatch agent. So let's create another association. And this time it will be called CloudWatch Agent Configure. And this time we're going to look for the Amazon CloudWatch Managed Agent document. All right, so Managed Agent is what we're looking for, which is this guy here. I'm going to leave all of these parameters the same except for this one here. So remember we had to set aside our ARN that we had before for our calendar. So we're going to, for our parameter store. So we're going to take our parameter store location and we're going to place that in there. Definitely check to make sure there are no white spaces. You may end up with an error if there are any. So we're going to go all the way down and leave everything the same. We're going to choose instances manually. I'm going to select both instances. We're going to go in cron rate, and of course we're going to do a rate of 1 day. And then we're going to create that association. So we see that it is now pending. I'm going to refresh. And it is successful. So now we have configured our CloudWatch agent. So now let's go to CloudWatch. It generally takes about 5 minutes before we'll start to see any of the metrics show, but I did want you to see that it was configured and that it does show up as a metric within CloudWatch. So here we have our CW agent. So this is what we deployed to State Manager. And we have 2 different ways of looking at the metrics. This has 12 metrics, right? Things like image ID, instance type, and this one just has the image ID, instance type, and instance image ID. So we're gonna look at the first one. Like I said, we're probably not going to have much here, right? Because we just literally deployed it and it didn't have time to get everything. But as you can see here, it does have some information, like our file system information. So you see here it has period is going to be 5 minutes. It's going to do an average, and the unit is going to be percentage. It talks about what the instance type is, the file system type, the region, and the instance ID and the image ID, which is all interesting information. So using State Manager, we were able to deploy the agent to our systems, and we were able to do that in a consistent, centralized manner where you're not manually going out and doing that. And we know that we have that consistent with what we want across the board for all of our systems. So let's go ahead and tear this workshop down. So what we need to do is go ahead and disable AWS config. So let's go back to Systems Manager. We're going to go back to our quick setup. We're going to do config recording first. And we're going to delete that configuration. And we're going to remove it from all OUs and regions. And just so you know what's happening in the background is that it is going to delete that stack in CloudFormation. Just so you know what's happening in the background. So you see here, delete in progress. So let's go ahead and go to config itself. We're going to go to settings. We're going to edit. And we're going to uncheck enable recording. And we're going to save that. So now the recording is off. So it's no longer going to do that. So if you want to delete the configuration information that has been stored, you're going to go into S3, because that's where we said we wanted to send them all, right? We're going to choose the S3 bucket that was created by our quick setup, just this guy here. We're going to empty it. Of course, we have to put in permanently delete. And then empty. Okay. So let's exit out of that. And now we can go ahead and delete the bucket. So we're going to copy the name of the bucket. And we're going to delete the bucket. So let's go ahead and remove the host configuration that we had. So we're going to go back to Systems Manager, quick setup. Okay, and then we're going to do delete configuration, remove from all OUs and regions. And of course, there's a CloudFormation template that is running to delete that. So while that's happening, I'll just delete that. And this is running now. So if we go to CloudFormation, it was deleted. So let's go back to Systems Manager. Quick setup. And wait for the configurations to load. And we're going to delete. So after this, we're going to go and we're going to remove the data sync resources that we created. So going to our data sync link that's within the workshop, we're going to go to the data sync web console. We're going to choose our data sync and we're going to delete it. Now we're going to go back to our S3 bucket where we synced all that inventory data to, and we're going to empty that bucket and then we're going to delete that bucket. All right. And now we're going to delete it. Now we're going to delete our command documents. We're going to go down to our documents, owned by me. We're going to select our org install app. We're going to delete that document. So we refresh. Owned by me, we should only have one. So now we're going to go to our change calendar. And we're going to delete that calendar. And now we're going to go back to our automations underneath documents. And go to owned by me, which we should just have this here. And we're going to delete that. Now let's delete our parameter store. We're going to select our parameter store and we're going to delete that. And last but not least, we are going to remove our state manager associations. So we're going to do agent install first, delete that. And then we're going to delete the CloudWatch manage agent association. And now we're all nice and clean and we should be good to go. Thank you for joining. Do you have any questions?